Any architect will tell you that the design and the shape of a wall has a big impact on how we experience the space around us. A dynamic wall, like what you see here, creates even more possibilities for rich interactions. This is a robotic surface, which can be configured to form a number of different shapes through the use of lightweight, programmable constraints. This person has a robotic surface in their studio apartment. They just came inside and they want to take off their jacket, but they're holding a bag of groceries. So the wall turns into a temporary shelf. It also forms a coat hook so the person can hang up their jacket. As the person leaves, the robotic surface raises the jacket out of the way and folds the grocery shelf back into the wall. How would you go about building something like this? One approach would be to motorize each joint as if you were building an industrial robotic arm with many degrees of freedom. But if you want to handle human scale interactions, those motors are going to have to provide a lot of torque. This adds weight and expense, so it's not really practical to build a shape-changing surface this way. We take a different approach. Instead of using high torque motors to drive the joints, we use low power motors to constrain them. Each cell pair in our surface is connected by two integrated hinges, which can either be left open or squeezed shut. By rotating a passive clamp, which is the white piece you see here, we can transform any of our joints from a rigid state to either a mountain state or a valley state. You can see the three states in the bottom right-hand corner of this figure. Once the column has been constrained, we squeeze it from the endpoints and arrive at our deployed shape, as you can see in the top right corner. Our surface consists of 4 fully actuated columns, which ride on the rails you can see at the left. We also include 2 decorative columns on either side. Here are some other examples of interactions. This person is using the robotic surface as a temporary desk. It can easily hold their laptop, and they can adjust the height. When they're done working, the desk folds right back into the wall. Here, someone is about to leave without their umbrella, so the wall gives them a reminder. Here, we're forming a small canopy to serve as a reading nook. The wall nudges a nearby light into place, so a person can sit down and read their book. In future work, integrating low-cost input sensors could allow for even more interactions. For details on our implementation and some simple control heuristics, please see our paper.